the cerebral cortex of NASA's unmanned planetary program, the Deep Space Network Operations Center. There are countless problem solvers in the space age, but only a few are qualified to solve problems in outer space itself. One age-old problem of outer space has to do with getting there.
I suppose it would be possible to fly a spacecraft on a straight line from one point to another in the solar system. It would require an exorbitant amount of propulsive capability. It surely is not the best way to do it. In fact, in flying from one place to another in the solar system, we use one of Keplers' laws, which tells us that the planets move around the sun on ellipses, and the spacecraft will follow exactly these same laws.
Ignition.
Obviously, to aim toward the planets with brute force alone is to miss the point entirely. Clearly, present-day space navigators look to the future by way of the past. Kepler's 3 laws stated how the planets orbit the sun. Newton explained why Kepler's laws work. Now, no matter how futuristic the problems, space navigators use Newton's and Kepler's laws as operating principles.
The way we get a spacecraft from Earth to Mars is to put the spacecraft in an independent orbit around the sun that necessarily intersects the orbit of Earth and the orbit of Mars. In fact, the launch vehicle has to impart enough speed to that spacecraft right after launch so that it will coast all the way from Earth to Mars once the launch vehicle burns out 30 minutes after liftoff.
To travel between 2 points in space, a craft coasts to its destination in orbit around the sun, just as if it were an orbiting planet. The path of a spacecraft from one planet to another is called a transfer orbit.
For the Viking mission, we were quite limited in selecting the transfer orbit because Viking was the most massive interplanetary spacecraft ever launched. The then most powerful launch vehicle, the Titan Centaur, could just barely get us to Mars. The classical transfer between 2 planets is referred to as the Hohmann transfer. We followed a transfer very close to this. It's one in which we launch from Earth tangentially at the lowest point in the orbit, that is the point closest to the sun, and arrive at Mars at the highest point, the apoapsis point, the most distant point from the sun.